This is an example of a hypothesis test for a population mean, sigma known, and the conditions are met to use a z-test. A doctor says the average length of stay in a hospital for patients involved in a crash in which the vehicle struck a tree is less than 6 days. A random sample of 20 lengths of stays for patients involved in this type of crash has a mean of 6.5 days. At alpha equal 0.10, can you support the doctor's claim? Assume the population lengths of stays in a hospital for this type of crash is normally distributed, and assume that sigma is equal to 2.3 days. The null and the alternative need to be set up in terms of the population parameter mu. And looking at the claim is that the length of stays for patients involved in this type of crash is less than 6 days. So as a mathematical statement in terms of mu, this will be mu less than 6, and this is the doctor's claim. Okay. Because this does not contain the case of equality, this is the alternative, and our null is that mu is equal to 6. Because this is a z-test, our test statistic will be a z-score, and the formula for it is x bar minus mu over sigma over the square root of n. What we observe minus what is hypothesized divided by the standard error of the mean from the central limit theorem. In this problem, x bar was given to be 6.5, n was 20, and the assumed population standard deviation was 2.3 days. So plugging into this formula, using parentheses around the numerator and denominator expression just to be on the safe side with the calculator, it always helps to use parentheses so the calculator will observe the correct order of operations. I get a standardized test statistic of 0.972 rounded to 3 decimal places. Making sure I did that correctly and put it into the formula. Just double checking. Okay, that looks good. Now I need to find the critical value using my level of significance of 0.10. Because this is a left tail test or a lower tail test, looking at the alternative, I will have 0.1 amount of area in my lower tail. This is an area or a probability. And I need to find the critical value, which will be a z-score. You could use your standard normal table. I'm going to use the normal CDF function from the distribution menu. I'm going to use the inverse normal function. When you're given an area and you need a z-score or an x value, if it's not standard normal, you would be using the inverse normal option. My cumulative area in this left tail is 0.10, and I have my tail as left, which is what I'm looking at. If you have an older TI-84, you just need to put in the cumulative area to the left of that critical value. There is no option to change the tail. I expect my z-score to be negative because it is below 0. And I get a critical value of negative 1.282. My standardized test statistic of 0.972 is well in the fail to reject region. If it was less than negative 1.282, I would reject the null. If it's greater than negative 1.282, I would fail to reject the null. So looking at the null and the alternative, the null is the quote-unquote winner. And to answer the question, because the claim is the alternative, can you support the doctor's claim? The correct way to say that is there is insufficient evidence to support the doctor's claim that the mean length of stays for this type of crash is less than 6 days.